This is BBC Bite Size with Chris Smith and with Ben Valsler. We're from The Naked Scientists. In this podcast, we're going to be drawing some graphs and also finding out what they mean. Ben?
Well, when we're talking about motion, it can be very useful to draw a graph so you can see what's happening. For instance, if you're moving in a straight line, the graph that's useful is a distance-time graph. This is where you make the x-axis time and the y-axis your position on an imaginary ruler put along the line.
Well, that makes sense. So how do I know, though, where to put the origin, the starting point on a graph like that?
Well, it doesn't really matter as long as everyone agrees, because it won't affect how the objects move. You could start at 1,000,000 metres, but it would make the arithmetic difficult, so you're probably better off picking something sensible. It's often conventional to make the origin where you start off, or if you're moving vertically, at the floor.
So what would the graph look like if I were to just sit down at 2 metres along your imaginary ruler?
Well, you would plot 2 metres on the vertical axis at 1 second. It would be 2 metres at 2 seconds. It would be 2 metres at 3 seconds. In fact, it would just be a horizontal line.
So what happens then, on the other hand, if I'm moving at, say, a constant speed?
Well, if you're moving at 2 metres per second and you started off at 2 metres, after a second you'd be at 4 metres. After 2 seconds you'd be at 6 metres. So again, you're actually plotting a straight line.
And what happens if I then start moving in the opposite direction?
Well, you can also think of this as your velocity being negative. So if you were going at 3 metres per second in the other direction, you started off at 6 metres. After 1 second, you'd be at 3 metres. After 2 seconds, you'd be at 0 metres. And after 3 seconds, you'd actually be at -3 metres.
So my position can be negative then?
Well, yes, it can. It makes no difference to the graph or the maths. So long as there's nothing physical in the way, like, say, the floor, your position can be negative.
So if I'm not moving, the graph line will be horizontal. If I am moving, it will be sloping. So can we work out what my speed must be from that slope?
Well, yes, if you're going very slowly, your position will only be changing a little every second, so the graph will be a very gentle slope. But if you're going very quickly, your position changes a lot for each second, so it's a very steep line.
And so can I use the steepness of that line to work out my actual speed?
Yes, if you can work out what's called the gradient of the graph, that's the velocity you're going at.
And how do I do that?
Well, you just work out how much the position is changing every second, exactly the same as how you work out speed normally. So if your position on the graph has changed from 10 metres to 30 metres in 5 seconds, your position has changed by 30 minus 10, that's 20 metres, in 5 seconds, so you're going at 20 over 5, that's 4 metres per second.
What happens if I'm trying to measure a velocity that's only happened over a very short time, though?
Well, if you don't have a very long line on your graph, if it's a constant speed, it's a straight line, so you can just use a ruler to extend the line out, and you can produce a journey with the same speed, but that's much easier to measure. You could, of course, draw a graph of your velocity.
And how does that work?
Well, again, you have time on the x-axis, but this time you have velocity on the y-axis.
And what would that graph look like if I, say, didn't move anywhere?
Well, your velocity would be 0 if you're not moving, so the line would just stay at 0. Or if your speed is, say, a constant 2 metres per second, then the graph would be a horizontal line at 2 metres per second.
So what does it mean instead if the line is sloping on this graph?
Well, this means that your velocity is changing, which means that you're accelerating. If the slope is constant, then the acceleration is constant. So a curved line would mean that the acceleration is changing.
So can I work out what the acceleration is from that?
Well, yes, this time if you work out the gradient of the graph, you'll know the acceleration. Again, a steep line means a large acceleration, and a gentle slope means a small acceleration.
And is there any way of working out your position from this velocity graph?
Well, you can't work out your starting point, but you can work out how your position has changed. Because you work out a change in position by multiplying a velocity by a time, you can work out your change in position by multiplying each speed in the graph by the time that you're going at that speed for.
Well, that's all very well if you're going at, say, a constant speed, but what happens if you're accelerating and your speed's changing?
Well, multiplying a velocity by a time is actually the same thing as working out the area under the velocity time graph. So if the velocity is changing at a constant rate, you can work out the area under the graph, which will be a triangle or a trapezium, and you can work out the area and hence how far you've travelled.